Okay, 5-9, day 2. We can multiply complex numbers using the distributive property, and we treat our imaginary parts as like terms. Recall that I squared equals -1, so we need to simplify using that fact. So the first thing I'm going to do is distribute. And then recalling the fact that I squared is -1. So it's 6i plus 10, and we rewrite 10 plus 6i. The second one, use FOIL. So the first, outers, inners, lasts. Combine our like terms. I squared is -1. So we have 20 minus 12, which is 8. I'll box that out too. All right, next example. We look at what we're multiplying here. We have 7 plus 2i and 7 minus 2i. They are conjugates. But we're just going to go ahead and multiply them using FOIL. And you'll see that when you multiply two conjugates, it's like multiplying a difference of two squares. Center terms go away. And 49 plus 4 and the last one you multiply the numbers, you multiply the i's, so you get -36. Pause the video and try the examples, then check yourselves with the answers. Okay, hopefully you were able to get those correct. We have one more thing we need to do, and that's that the imaginary unit can be raised to higher powers. And there's a nice table here. As you can see, the pattern repeats. So it repeats that you have 4 different answers depending on what power of I you have. So I to the first is I, naturally. I squared is -I. But I to the third, you can simplify as I squared times I, and I squared is -1. So -1 times I is -I. And then I to the fourth is I squared times I squared, which is -1 times -1, which is 1. So it'll be any one of 4 answers that it can be simplified to. I, -1, -I, or I. I'm going to hopefully show you maybe a shortcut. They're the only 4 that you really need to learn. So let's go and simplify some powers of I. First off, we're not going to worry about the negative 3 out front. We're just going to look at I to the 12th. We take the power 12 divided by 4, and we look at the remainder. The remainder is 0. So in my list, we had I to the first, I to the second, I to the third, I to the fourth. And because there's no remainder, it's the same as I to the fourth. So this would be negative 3 times 1, which is negative 3. So think of your remainders are over here. So this is a remainder of 1, 2, 3, 0. Okay, so I to the 25. So you take 25, divide by 4 is 6, the remainder of 1. Remainder of 1 is I. So this would simplify to I. Okay, what if you don't like that method? If you don't like that method, then you have to come up with still powers of, not necessarily powers of 4, but powers of 2. So if we look at the check it out, I to the 7th is the same as I to the 6th times I. We need basically this to be I squared to some power. So this would be the third power. Because we know power to powers we multiply. So I squared is negative 1. Negative 1 to the third power is odd, so it's negative 1. So this would be negative 1 half I. And you may not like that method any better. There's really no easy way. I think the remainder way is the nicest way. So if we look at the next one, again, take 42 divided by 4, look at the remainder. Okay, it would be 10, and the remainder will be 2. Looking at your list, a remainder of 2 is negative 1. Dividing complex numbers is kind of almost like rationalizing the denominator. We need to make sure there's no complex numbers in the denominator. So you multiply by the conjugate. So recall that the conjugate of A plus BI, the conjugate is A minus BI. So I'm going to multiply this by negative 8i. And we learned how to multiply by distributing. Now we can simplify. That should be a squared. We can simplify. Remember, I squared is negative 1. So we get negative 24i plus 56 over 64. Can reduce that all by 8. And you'll see that the book will separate that into an I term and a real term. And once again, we should write it in a plus bi form. So yes, these are a little long. Okay, and the next one, and multiply by the conjugate, which is 2 plus 4i. Distribute, okay, so you have to use FOIL. So we have 10 plus 20i plus 2i plus 4i squared all over. And hopefully maybe you realize that this is like a difference of 2 squares here. So you don't have to do those center terms, but that's solely up to you if you feel more comfortable. Combine like terms. And I'm also going to change that. I'm going to change the bottom here. This is -1. This is plus 16. 10 minus 4 is 6. 20. Everything can be reduced by 2. And then we write it in a plus bi form. You have 2 to try. Pause the video and then check your answers. Hopefully you were able to follow along with those, and we just finish out. Graph the 2 complex numbers on the complex plane, find their sum, difference, product, and quotient. So graphing, remember that this is the real number part, the x. This is the I. So 5 plus 6i is here. 3 minus I is there. They both get drawn into 0. Follow the same slope. It's up 6 over 5. So this has to be up 6, 1, 2, 3, 4, 5, 6 over 5, 1, 2, 3, 4, 5, somewhere about there. So there's them added. And what would that be? 3 onto 5, which is 8. So this would be, so adding, we would get 8 plus 5i. Okay, subtracting. We get 2 plus 7i. Multiplying, use FOIL. Division, remember that you need to multiply by the conjugate. So distributive or FOIL. This is -1. So wait, 15 minus 6 is 9. And this ends the lesson.